Hi, welcome back, Introstat students. So today, for this video, I'm going to try to attempt to do the Unit 10 on sampling distribution, the unit test. There are only 9 questions, so I'm just going to go through it, and hopefully this will be a review. Right? Thank you. Let's begin. It's loading. It's okay. So, are you ready for the test? So all set for the unit test. Let's go. All right. So Tony runs a restaurant that receives a shipment of 200 oranges every day. According to the supplier, approximately 11% of the population of these oranges is overripe. Suppose that Tony calculates the daily proportion of overripe oranges in her sample of 200. We can assume the supplier's claim is true and that the oranges each day represent a random sample. What will be the shape of the sampling distribution of the daily proportions, of overripe oranges? So, first thing first, when they are asking for shape, right, they are either, is it skewed to the left or is it skewed to the right or is it normal or is it neither of those? Right? So, in order to do shape of a sampling distribution, especially for proportion, you need the n and you need the p. So in this case, the n, it says that the sample is 200. Okay. And then the p, which is the population proportion, which is 11% right here. So as long as it passes these two conditions, n times p, right? As long as it's greater equals to 10. And n times 1 minus p. As long as it's greater equals to 10, then the shape would be approximately normal, right? It will be like this. So let's do the math. So 200 times 0.11, okay. 200 times 0.11, if you do it on your calculator, is 22. And that is definitely more than 10. And then we take 200 times a 1 minus 0.11. Now, if you think about it, this is 0.11. This is 1 minus 0.11. And so this number, right, it will be bigger than this number. And if we are multiplying by the same 200 here, therefore this number will be more than 10 because 1 minus 0.11 is 0.89. So, ladies and gentlemen, if you can see 200 times 0.89, 200 times 0.11, this number is going to be big, isn't it? It's going to be bigger than 22. Therefore, it's greater than 10. So, you can now safely say that the sampling distribution will be approximately normal. All right? Um, okay. So, next question. Question 2. The dot plots below show an approximation to the sampling distribution for 3 different estimators of the same population parameter. Okay, this is pretty tight, so low variability. This is high variability because it's spread out. Now, whether is it high bias or low bias, I don't know until I find out what the population parameter is. So here it's low variability, but then here the mean, right, the average is different from this average and this average. Those two are the same. They have the same mean, right? In fact, they have about 2. Their mean is about 2. Here the mean is about 4. So let's check. If the actual value of the population parameter is 2, which dot plot displays the estimator with both high bias and low probability. High bias. So high bias means it's not on 2, and which is this one, right? This is on 4. And with low variability, it's pretty, it's pretty tight. So I would say the answer is C, right? High bias, low variability. Okay, let's go on. Question number 3 now, right? A CAM accrediting association has 2,400 camps in their association. They claim that 45% of their camps offer specialized programs for individuals with disabilities. Suppose you contact a simple random sample of 200 of the camps and ask them whether they offer specialized programs for individuals with disabilities. Assuming that the association claim is correct, what is the approximate probability that between 40 to 50% of the CAM reply yes to your question? Okay, so if I look at all the options, they all have a value, which means, right? So I'm saying that, do you need to check for whether the sampling distribution is normal or not? You don't really need to, but just in case, right? Just review. So here you're talking about qualitative data, right? Categorical, because it's a yes or no question, and they would either answer yes or no. So it's a proportion problem, right? It's a proportion, and it's not a mean problem. It's not an average problem. So if you do the n times p, is it greater or equals to 10? And is the n times 1 minus p greater or equals to 10? And you'll see that both will be satisfied because the p is right here, 0.45, right? They claim that 45% of their camps offer specialized program. And this is your n. N is 200, right? Sample size 200. If you take this times this, right, both will be greater than equals 10. And if you do n times 1 minus p, 1 minus 0.45 is 0.55. And therefore, if this is greater than 10, this will be also greater than 10. So we can now safely assume that the sampling distribution will be approximately normal. And the mean here will be 0.45, right? Because you are looking at the population parameter here, population proportion, which is 0.45. And they want to see if it's what's the probability between 0.4 and 0.5, right? See, p hat. So this is the distribution this is the mean of the sampling distribution of the sample proportion. So this is what they're trying to find for you, right? You're trying to find that for them, right? This is what they're asking. So here, because it's approximately normal based on this condition, we can do the normal, right? Normal CDF, right? We need 4 things. We need 4 things. What are the 4 things? We need the lower bound right here. We need the upper bound right here. And we need the mean. Mean of the sampling distribution is 0.45 right here because it's the unbiased estimator, right? This is the true population proportion. The sampling distribution, the mean, right, will have to be the same, right? So, but what is the standard deviation? If you remember, the standard deviation of the sampling distribution, right, of the sample proportion is p times 1 minus p divided by n, which is 0.45 times 1 minus 0.45 divided by 200, right? So if you put this in a calculator, right, it will be second square root sign, second square root sign, second square root sign, and it's 0.45 times 1 minus 0.45 divided by 200. Okay, so Actually, you can put all of that right here. You can put all of that right here, and you can straight away do it on your calculator. So 0.4 and then 0.5, 0.45. Okay, so let's try our attempt to do that all in one shot and see if that works. So I will go to second vars and I'll go to normal CDF. Now here you see the lower, I said the lower was 0.4, right? They ask you for 40% and 50%. So 0.4, the upper should be 0.5, and then the mean is 0.45, right? Unbiased estimator right here, 0.45. Now here is where we have to be careful. So I'm going to put second with the square root sign. Now I'm going to do everything that I can together in one shot. And I know that my P is 0.45. So the formula was what? Square root of 0.45. So 0.45 times, right? I can close the bracket. I can open another bracket times, well, actually would not be good. Actually it does work, but I want to put everything together. So second square root. Okay. So 0.45 times 1 minus.
As a regular reminder, we'll be closing at 2 o'clock today, so be aware.
Okay, we're closing at 2 o'clock today. So 0.45 times 1 minus 0.45 divided by 200, which is the sample size. Okay, and then close the bracket and enter. So I put in the standard deviation, right, of the sampling distribution of the sample proportion. So it's 0.84, round to the nearest 2 decimal place, 0.84, right here, right? So question number 4, patients recovering from a stroke have their grip strengths measured in each hand to monitor their progress. A certain population of over 100 male patients have grip strength in their dominant hands with a mean and standard deviation of 41 kilograms and 9 kilograms respectively. Suppose that we take a random sample of 4 male patients from this population and calculate X bar as the sample mean grip strength from each group of patients. What is the shape of the sampling distribution of the sample mean? Now, since if you look at the sample size, now here we are dealing with means now, right? We're not dealing with proportion, we're dealing with means. Now we have to be careful. When we deal with means, we have to see if the central limit theorem is applied. And our central limit theorem says if the sample size is large, now how large? More than 30. But here the sample size is only 4. Wow, it's really small. So let's look at what the population is. Is the shape of the population normal? Let's check. Patients recovering from a stroke with the mean. So no, it doesn't say, right? It doesn't say if the population, if it's skewed to the left or if it's skewed to the right, so we do not have information right here. We do not have enough information to determine the shape of the sampling distribution, because if the population is normal, then we know that the sampling distribution will be normal as well. And if the sample size is more than 30, then we do not need to know, right? Even if the population is skewed left or skewed right, if the sample size is more than 30, we know that the sampling distribution, the shape will be approximately normal. But we don't have all this information, so we don't know. Okay? So what does it say here? So unknown, we don't have enough information to determine the shape. The sample size is very small, n equals to 4, which is less than 30. So we need to know the shape of the population to determine the shape of the sampling distribution. But we don't know the population shape, okay? So fifth question, suppose that 93% of approximately 1,000 total dogs sold by a shelter are up to date on their shots. Administration plans to take a SRS, simple random sample of 40 dogs sold by the shelter to see what proportion of the dogs sample are up to date on their shots. So what are the mean and standard deviation? Okay, look at the options. What are the mean and standard deviation of the sampling distribution of proportion? All right, so here we need to be careful. So here we are asked to find the mean, which is this symbol, right? And that should be equals to our P. And our P is right here, 0.93, right? Because suppose that 93% of approximately 1,000 total dogs total. So that tells you that's the population. In the population, there's 1,000 total dogs sold by the shelter. And the standard deviation of the sample proportion, right, is this symbol. It's not this formula. Square root of P times 1 minus P divided by N. So it looks like 0.93 times 1 minus 0.93 divided by 40, right? The sample size is 40. So if you look at what is 1 minus 0.93, 1 minus 0.93 will be 0.07. So let's look at the four options that we have, right? Let's look at this. So here it's, sample size is 1,000. Nope, the sample size is only 40. But we need the 40 in the denominator. Nope, not B. So but then the difference between C and D is that the standard deviation of the sampling distribution of the sample proportion, they're correct, right? See, 0.93 times 0.07 divided by 40. But the only difference here is the mean. Here they take the sample times the P, N times P, and that's not what we want. We want this. Okay, so houseflies now. Houseflies have pretty short lifespan, poor things. Males of a certain species have lifespan that are strongly skewed to the right, with a mean of 26 days and a standard deviation of 12 days. Okay, so a biologist collects a random sample of 9 of these male houseflies and observe them to calculate the sample mean lifespan. Okay, so I can tell you now, if the population is strongly skewed, they say males of a certain species of lifespans that are strongly skewed to the right, and strongly skewed looks like this, to the right, right? Strongly skewed. Okay. And we are taking samples, how many? Only 9. 9 of sample size of 9, and observe them to calculate the sample mean lifespan. We can't calculate because the sampling distribution of the sample proportion is, we don't know if it's normal or not, because the sample size here is way too small, right? If it's above 30, then we can assume that the sampling distribution is approximately normal. But this is 9. 9 is way too small. And so we cannot determine the shape of the sampling distribution. And if we cannot determine the shape of the sampling distribution, we can't find the probability. Right? So this question is right here. We cannot calculate this probability because the sampling distribution is not normal. Right? Okay, let's look at what they say. Since the parent population is not normally distributed, because we were told it's strongly skewed to the right, The small sample size will result in a sampling distribution that isn't normal. Okay. All right, so look at this. This is question 7 now. A certain region of America with over 500,000 household has a mean household income of 70,000 with a standard deviation of 20,000. Economists plan to take random sample of 625 households and calculate the sample mean, right? Income X bar for each sample. So there is a sampling distribution of X bar, right? The X bar is the mean of 625 households. So calculate the mean. All right, to calculate the mean, this is your mean, right? Your mean of the sampling distribution will be the mean, right? Will be the mean of the population, which is right here, 70,000. Right, 70,000. And the standard deviation of this sampling distribution of X bar is none other than sigma divided by root n. So this is your mu, right? And this is your sigma. This is your sigma, your standard deviation of your population. This is the mean of your population, the average of your population. So standard deviation is 20,000 divided by square root, sample size is 625. If you put that in your calculator, 20,000 divided by root 625, that gives you 800. All right, 800. So the mean is 70,000 and 70,000, and the standard deviation of the sampling distribution of X bar is 800. So 70,800. 70,800. Sweet. Okay, question 8. The United Kingdom Forestry Commission reports that 43% of the 3.16 million acres of woodland area in the United Kingdom had certification identifying them as substantially managed in 2016. Suppose an employee took a simple random sample of 400 of the acres and saw that the records show that 47% of the sample acres had that certification in 2016. Assuming that the Forestry Commission reports is accurate, what is the approximate probability that more than 47%? So you're trying to find, right, when probability that the p hat, the sample proportion, is more than 70.47. So in this case, if you look at the options, it looks like it can be calculated, right? The probability can be calculated. And if that's the case, if probability can be calculated, that means that the conditions, the conditions for the sample proportion, right, for the sampling distribution is approximately normal. Because what's the condition? N times p greater equals to 10, and n times 1 minus p must be greater equals to 10. And here the n is 400, so it's rather big. And the p is 0.43. Yeah, so if you take this times this, definitely greater equals to 10. If you take 1 minus 0.43 times this, it must be greater equals to 10. So, so if it's normal, we need to use the normal CDF, right? The sampling distribution is approximately normal, and we need 4 things. And I hope you would remember this by now. So the first thing is, if it's greater than, so the mean is 0.43, because that's the population proportion. And we are trying to find probability of 0.47 and more, right? Greater than 0.47, so we are shading to the right. So if that's the case, our lower bound is 0.47, our upper bound is 99999, and our mean here, right here, is 0.43, and our standard deviation Our standard deviation has this formula, right? Standard deviation is square root of p times 1 minus p divided by n, which is p is 0.43, right, times 1 minus 0.43 divided by n, in this case is 400. So I'm going to try to put this into the calculator, right, so that I don't have to work it out twice. I just need to put this value right here. So 0.479999. Okay, so let's go. I think I can remember all that. So second bars, if I go down to normal CDF, so my lower bound, right, is this 0.47. And my upper bound is 99999. And my mean is right here, 0.43, 0.43. And my standard deviation is, okay, I already have it there, right? So I just need to change the 4 and the 3, change this to a 4 and a 3, and change this to a 400. Huh? 0.05. 0.05. And all this would work because it's round to the nearest 2 decimal places. Yeah, so 0.4. All right, thank you. Let's go to the last one and we will be done. So male mosquitoes have pretty short lifespan. Oh, I thought we did this. Males of a certain species have lifespans that are strongly skewed to the right, with a mean of 8 days. Oh, okay, and standard deviation of 6 days. The biologist collects a random sample of 36. Yay! Why am I happy to see 36? Because it's greater than 30. So if it's greater than 30, we can now assume that the sampling distribution, right, the sampling distribution of the x bar of the sample mean will be approximately normal. And we can use the normal CDF to figure it out, right, to find the probability. As you can see, it's no longer E, right, even though they tell us that the population, right, see, the males of a certain species have lifespan that are strongly skewed to the right. Even if the population is skewed, because we have a large enough sample size, 36, we can now assume that the sampling distribution is approximately normal. So if I were to draw it, it will look like this, right? So here the mean will be 8, right? 8 days. And they ask what's the probability that the sample mean is greater than 10, right? It exceeds 10. Where's 10? 10 might be here. So 10 straight to the right. So this is towards infinity, right? It's going to infinity. So here we will do a normal CDF. Same thing, 4 things, right? According to the diagram, what is the lower bound? 10. The upper bound is going to infinity, which is 99999. The mean is here. 8 is your mean. And standard deviation of the sampling distribution, do not use 6, because the standard deviation of the sampling distribution of the sample mean is sigma divided by root n. So what is 6? Sigma is 6. The population standard deviation is 6 divided by root 36. I know what root 36 is. Root 36 is 6. So 6 divided by 6 is 1. So here, the standard deviation of the sampling distribution is 1. If you remember all that, I'm going to clear and then go to the normal CDF, 8 and 1. Okay, so second bars, go to number 2. And what was my lower bound is 10. Upper bound is 9999. Oops. My mean is still 8. All right, that hasn't changed, but my standard deviation of the sampling distribution has been reduced to 1. So it's 0.02. So it looks like this will be the answer. Whew, thank you very much. Hope this helps. If you have any questions, let me know. Thank you very much.